So now we are continuing with our discussion of rational functions. So we had seen this function x plus 3 over x squared minus x minus 2 that factors as these x minus 2 and x times x plus 1. So here we notice that x equals negative 1 is a vertical asymptote and x equals 2 is another vertical asymptote, because what happens is this, that is, as x approaches negative 1, say it approaches negative 1 from the left. So what I mean is that x is this is negative 1 and x is approaching negative 1 from the left. So in that case, the y value or the function values, they go to infinity. Now once this happens, it's a vertical asymptote, but in this case, even if I go to right hand side to negative 1 from the right, it still goes towards negative infinity. But as I said, as long as the function values go to negative or negative infinity on any side of the x value, that value produces a vertical asymptote for us. And likewise, x equals 2 is a vertical asymptote. Okay. Now, another thing to notice here is this. Look at this. Look at the behavior of the function as x approaches infinity. All right. So for the values of x approaching infinity, well, we don't have large enough values of x here. So what we can do is that we can, let's just go from negative 50 to 50. I'm not trying to say that 50 is infinity, just, relatively large enough values. And what is it doing? It's taking too many points in sample points, or why is it showing the graph like that? Okay, just because we didn't let it go by default. Okay, so you can see the values of the function are decreasing, because you can see it has adjusted the scales here. Or we can create a table of values and see that how it would behave when we are doing this, letting x go to positive infinity or negative infinity. All right. So you saw that you can do this in your graphing calculator, but I'm just taking Excel here so that we can just do it a little fast here. Okay. So here what I'm doing is I'm going to type large values of x. Large means that just like in thousands, not in billion or trillions. Okay. So, well, didn't fit. All right, so fits here. Okay, and what we would do here is that we are going to just type in our function x plus 3 over, okay, x minus 2, and this is x, and we want to keep it variable, so that's how we would work on it. Okay, then x plus 1, and let's do this. So what happens is that so we have okay, just a moment, I had to close the parentheses here because I did not pay attention to the order of operations. So it shows that this is 0. Well, when I go to more digits after the decimal point, it shows us the value is very small. And you can see it becomes even smaller and smaller and further smaller, right? So this is what happens as it, as x goes to infinity, right? And for negative infinity, let's just go by this, negative 1000, negative 2000, and then, okay. All right, so again we have to make it fit, and that would be, we have x plus 3 divided by, you can see this, I'm clicking on this as x because I want to just let it be a variable, and You can use your calculator if you find it confusing. So it shows as -0, and then if you look at all the values, you can see, well, these are, ignore these because these are the other values that, okay, so right here. So you have x going to 0 even as x goes to -infinity. Now in this case it goes to 0 on both the sides, but actually you don't really need for it to go to 0 on both the sides. If it goes to 0 just on one side, it will be a horizontal asymptote. Okay, so what did we notice? That as x goes to infinity, our y goes to what? 0, and as x goes to -infinity, our y still goes to 0, and this makes y equals 0 a horizontal asymptote, right? Okay, and then likewise, say you had this, I think there was another function that we saw a while ago. Yeah, let's look at this function that we had seen in our graphing calculator. Okay, so here graph looks like this. So as x goes to infinity or -infinity, let me just go ahead and give it larger x values. All right, and see what happens. Okay, so you can see that this stabilizes near one point, and this is y equals 1 if you look at this, right? Okay, so or just go ahead and graph y equals 1 in here. Okay, all right, and so if we graph it, you can see that the function approaches the value 1 on either sides. And again, it doesn't have to do it on either sides, just 1 is enough, right? So here for this function, what did we notice? So we noticed that y equals 0 is a horizontal asymptote. Now you can look at this, look at a rational function and tell it by, or determine by looking at the expression that where the horizontal asymptotes are going to occur. So let me clean the slate and start with a newer example. So now let's look at this function, and all we want to discuss is the equations of horizontal asymptote or asymptotes. Okay, so in this case, you can see that the numerator is a polynomial of degree 1 and the denominator is a polynomial of degree 2. So what you find is this, that the degree of the numerator, okay, is less than the degree of the denominator. Okay, all right, so what happens in this case then? In this case, your horizontal asymptote is going to be y equals 0, or simply the x-axis. Let's just look at this, look at a graph of this. All right, so let me create a graph here. So here is a graph, and you can see this, that as x goes towards right hand side, the y values come closer and closer to 0, and of course it does have vertical asymptotes at x equals positive actually the one of the vertical asymptotes is that x equals 1, and the other one would be at x equals -5/6. So but we are interested in horizontal asymptotes. So notice this, as x goes to infinity, this approaches 0, and it goes towards 0 even on the left hand side. In this case, we can just numerically verify it, and in this time, instead of Excel, let's use calculator. Okay, so let's erase these guys here, and what we have is x minus 3 over 6x squared minus x minus 5. Okay, and then we want to set the table, so we will go for the table set. So let's go to the large values, and let's stick to -100, -200, etc., and see what it gives us. So if we look at the table, you can see that as we approach negative values farther and farther to the left, the function goes towards 0, and we could have made it like -1000, -2000, etc. Okay, and you will see the values become smaller and smaller. Okay, so here horizontal asymptote is y equals 0. On the other hand, if we have, say, a function, sorry, I messed up the equation there. So say we had another function, say that was given by, say, y equals, okay, say, let me just write 6x square. I don't know why I'm writing 6 so many times. Okay, minus 5x minus 1. All right, and then we write 2x square minus, say, 3x. All right, and let's put a -2 here. Okay, so in this case, what you have the degree of the numerator. Okay, I'm abbreviating it. It is the same as the degree of the denominator. Pardon me, I don't like writing like this, but it's okay. All right, so here we have the degrees the same, right? And notice what happens here if we have a rational function like this. So in here, you can see that 0 is, let me just bring it in our viewing area, okay, that y equals 0 is not a horizontal asymptote. Rather, as x goes to -infinity, we can notice right here that once again, you can see this value is 3, and that's what it seems to be approaching at. So let me put y equals 3 in here. So see, on this side, it approaches the value 3. Let's enlarge the values, say -20 and 20. Okay, we had to do that for the other function also in this. So let me do that. Okay, so you can see on both the sides, it's approaching the value y equals 3. So in this case, what happens? Y equals 3 is a horizontal asymptote, right? It's a horizontal line. We call it horizontal asymptote. Now, let me show you quickly an analytical reason for this. That is, if you did this, that is, you have a rational function here, and say we decide to do this. That is, we decide to divide both the numerator and the denominator. Okay, sorry about that. Both the numerator and the denominator by the highest power involved here, which is how much? X squared. Okay, and then after that, we let x go to infinity or -infinity. So here we go. All right, so what does this become? Let me enlarge the fonts here. Okay, so in this case, what you have is right here. So in the numerator I should have put the parentheses, but this, all right. So in the numerator I have 6 minus, if we carry out the division, 6x squared over x squared would be 6. Then negative 5x over x squared would be negative 5 over x, and then I got negative 1 over x squared, right? And on the denominator we get 2x squared over x squared is 2, and then we get 3 over x, and then we get negative 2 over x squared. So now what will happen is this, that as x goes to infinity or negative infinity, this quantity will become smaller and smaller and smaller, and so will this quantity. All right, so this would go to what? 6 over 2 as x goes to infinity or x goes to negative infinity. That's why y equals 3 is a horizontal asymptote here. So when the degree of the numerator and the degree of the denominator are the same, what you do is you just take the ratio of the leading coefficient, and y equals that value gives you horizontal asymptote. All right.